Alright, here is example 7 with the chain rule. We have y equals the arctan, in other words the inverse tangent, of 9x plus 5 natural log of x squared plus 4. So kind of a big mess on the inside here, right? But again, we're going to use the chain rule, so we want to identify the big guy and the little guy. So you'll notice the big guy is arctan, right? It's affecting everything. So if you want, you can start at either of these x's and then just work your way out. And you'll see, okay, here's x multiplied by 9. Then here's another x, square it, add 4, and then take a natural log, and then multiply by 5, and then finally add that to this 9x. But then after that, then you take the arctangent of the whole thing. So the arctan affects everything. Okay, so that's our big guy, is arctan. So chain rule says that y primed is going to be the derivative of the big guy evaluated at the little guy. The big guy is arctan. Remember what the derivative of arctan is. Whoops. Oh, bad, very bad. Derivative of arctan of x. Remember, that's just another way of writing tangent inverse, right? Derivative of arctan of x is 1 over x squared plus 1. Okay? So derivative of arctan of x is 1 over x squared plus 1, but chain rule says evaluate the derivative of the big guy at the little guy. Okay? So it's derivative of the big guy evaluated at the little guy, and this whole thing in here is the little guy. Alright, so this is going to be kind of a big old mess here, but let's go ahead and do it. So we're going to have derivative of the big guy evaluated at the little guy. It's going to be 1 over, let's see, erase this here, over 9x plus 5 natural log of x squared plus 4, alright, that whole thing squared, okay, and then plus 1, alright, now we can put the 1 on top here. So derivative of the big guy evaluated the little guy, because remember, the big guy is arctangent, right, and the derivative of arctan of x is 1 over x squared plus 1, but we want to do the derivative of the big guy evaluated at the little guy, so instead of x squared, it's going to be the little guy squared, and the little guy is this big mess in here, okay? So then chain rule says multiply by the derivative of the little guy. So now we multiply by d dx of the quantity 9x plus 5 natural log of x squared plus 4. Ugh. Alright, what a mess. What a mess. But not really too bad, I guess, right? So here, you know, if you just remember the chain rule here, derivative of the big guy evaluated the little guy, and then times the derivative of the little guy, it's not so bad. Sometimes it might be kind of complicated identifying what's the big guy, what's the little guy, or it might be complicated if you have functions inside of functions inside of functions and so on. But this one, you know, it's kind of an ugly function, but it's not really all that bad. You know, it's not too difficult to see that, okay, the arctangent affects everything, so that's the big guy, right? And then we just have to remember, okay, derivative of arctan of x is 1 over x squared plus 1. So then chain rule says do this here. And another way to remember this is if you want to do the derivative of arctan of a thing, then that's going to be 1 over that thing squared plus 1 times the derivative of that thing. Alright? So that's another way to remember that there. Kind of like the same thing we were talking about with, you know, the derivative of e to a thing is just e to that thing times the derivative of that thing. And it's another kind of thing with natural logs and so on. You can think of arctans, you know, in a similar way. But anyway, let's get back to this here. So now y primed is going to equal, let's just leave this as it is. We definitely don't want to FOIL that, right? That's just going to be a disaster. So let's not do that. But what are we going to have? We're going to have 1 over, so all this stuff is just going to stay there, really. 9x plus 5 natural log of x squared plus 4, that whole quantity squared, oops, and then plus 1 like that. Alright, and then we want to multiply by what? Well, here we can differentiate this term by term, so derivative of 9x is just 9, that's good. And then what happens here? 5 is just a constant being multiplied, right? So remember, if you have a constant multiple in the derivative, you can just pull it out. So the 5 is just still going to be there. And then here's natural log of a thing. So if you want to do the derivative of the natural log of a thing, that's 1 over that thing times the derivative of that thing. Okay? Close bracket. So again, derivative of natural log of a thing is 1 over that thing times the derivative of that thing. Okay, in this case, that thing is x squared plus 4, so the derivative is 2x to the first plus 0, or in other words, just 2x. Okay, so now let's simplify this. This is going to be y primed equals 1 over 9x plus 5, natural log of x squared plus 4, parentheses there, are necessary, we do need those, and then square brackets, also necessary, squared plus 1, and then times what? This is going to be 9 plus 5 times 1 times 2x is going to give us 10x over x squared plus 4. Alright? And that's actually just going to be our answer there. So let's, we could put this on top over here, but then we'll have a complex fraction, we'll have a fraction inside of a fraction, and those are best to avoid. So we just leave it like this. So this is a huge, ugly mess, but that's actually not too uncommon if you, start with something like this. It doesn't really look too bad, right? It's kind of a goofy function, kind of ugly, but when you take a derivative, it just gets a whole lot worse. But anyway, we don't have to FOIL this or expand it or anything, so that's good. But anyway, if we have y equals arctan of this mess here, then y primed, its derivative is going to be this stuff here. And that's example 7 with the chain rule.